Hello, my name is Michael Knight. Welcome to my channel. Today we're going to be working on parallel circuits. So we're going to work out a couple of problems and cover the basics of parallel circuits. So the first thing we're going to do is we're going to do our pie charts that we generally use. Write them pretty big here. EIR. And these are our Ohm's law formulas. PIE. So we can do most of our stuff with these two formulas right here, these two pie charts. So starting out, the first problem I want to work today is we're going to be doing parallel circuits. So let's start out with an ET of 12 volts, R1. Let's see, let's do IR1 equals 2 amps, IR2 equals 3 amps, and IR3 equals 5 amps. Okay, so this is the first problem. Now, it's been my experience that people do a lot better on working out these problems if they draw them out first. Sometimes you can work them like this and solve everything, no problem. But as the problems get more complex, it's better to be in the habit of drawing them out, and that usually works the best, and you have a little better success rate. So we're doing parallel circuits now, and we'll do 3 resistors. I'll put one in here, one in here. Okay, so ET equals 12 volts. And I generally circle that. That way I know what numbers I actually started with. So if I have an error, I can go back and fix it pretty easy. So IT equals, RT equals, and PT. These are the main things we're going to be looking for. Voltage or electromotive force, current, resistance, and power. So on R1, ER1 equals, IR1 equals, R1 equals, PR1 equals. So it's a good idea to get in the habit of writing this stuff out so you know what everything is as you go. IR2 equals, R2 equals, and PR equals 2 equals. And that'll give you the basics to remember. Let's see, this is 3, IR3 equals, and R3 equals, and PR3 equals. So that sets up our problem to work. Now we have 12 volts. I put that on there. IR1 has 2 amps. IR2 has 3 amps. And like I said, I generally circle these so I know. And on these little problems, it's not that big a deal. But as you get into bigger problems and more complex problems, it's pretty nice to be able to remember what you started with in case you have to back up and restart on something. All right, so current. We talked about in series circuits, the current is the same all the way through the circuit. Well, in parallel circuits, the current is, add them all up in each series branch or each branch. So if you look at this is like a series circuit with 2 amps. This is like a series circuit with 3 amps. And this is like a series circuit with 5. So if you add all those up, that's 10 amps total. And so that would be your total current. Now voltage in series, remember we dropped each series, a series circuit path drops all the voltage. And that's the same thing here. So each path has to drop all the voltage. So this drops 12 volts. This circuit has to drop 12 volts. And that path has to drop 12 volts. And that's how I think about it. Each path has to drop all the voltage, always. So that's a given. Now, once you have two things on any resistor or even on the totals, once you have two things, you can solve the rest of it easily. So we have volts and current. So volts divided by current equals resistance. So we can get that right here with our calculator. And we just do 12 volts divided by 10 amps. And that is 1.2 ohms. And then we can do for P is I times E. So 12 volts times I is 10 is 120 watts. 120 watts of power we're going to use. Okay, so we got that one. Let's work this one. 12 volts, 2 amps. 12 divided by 2 gives you 6 ohms of resistance. And then I times E, 2 times 12 will give you 24 watts. No problem. All right, 12 and 3, 12 volts, 3 amps gives you 4 ohms. And then power is I times E, so 12 times 3 gives you 36 watts. All right, next do the next one. 12 volts, 5 amps. 12 divided by 5 gives you R, so 12 divided by 5 equals 2.4 ohms. And then I times E equals power, so 12 times 5 is 60 watts. All right, so we talked about in series, the resistors, the voltage drops add up. In parallel, each path drops all the voltage. And like if there were two resistors here, they would split. They would still drop all the voltage, but each one would drop part of it. And we'll do some combination circuits later on. But so each path drops all the voltage. The current in each path adds up to the total. Now the resistance is a little different. For the resistance, we have to do the reciprocal formula. Is probably the way we use it the most. There's another couple formulas that we can use, but I'm mainly going to talk about the reciprocal formula here. So it's 1 over, and that would be 6 ohms plus 1 over 4 ohms plus 1 over 2.4 ohms. That's the reciprocal formula. So it's the reciprocal of the resistance plus the reciprocal of the next resistance plus the reciprocal of the next one, and the reciprocal of that answer will give you your total RT. That's your formula. So let's just try it here. Let's do, and on this calculator you hit 6 and that X1 minus 1 button, reciprocal, plus 4 reciprocal, plus 2.4 reciprocal equals reciprocal equals 1.2 ohms. And see, that's what we had over here. So with Ohm's law, you can always check your answers. You can go back and you can do different formulas and check your answers and make sure they're right. So that's our resistance. Now the power, I talked about power before. All the powers in each branch add up, and that should be the total power. So 24 and 36 is 60, plus 60 is 120. So that problem all works out. That all works out correctly. So let's do one more. Let's do another one here. Let's do how about R1 equals 50 ohms, R2 equals 60 ohms, R3 equals 300 ohms. And then we'll do for the voltage, we'll do ET equals 24 volts. All right, so we'll draw the circuit again. Draw a battery here. Ooh, got a little carried away there. That's all right. Get our 3 resistors. All right. Now we put 24 volts. And then we have 50 ohms. And we have, 60 ohms. And we have 300 ohms. There we go. So how are we going to work this? Well, first of all, we know that each circuit is going to drop all the voltage. So that's going to put 24 volts on all these. Right there. So we can actually solve all those now. We also know, let's see, we can do the reciprocal and get our total resistance. So let's just do that. There's other ways we could do it. There's many ways we could work this problem. But let's do the reciprocal method real. You need to get used to doing this because we'll be doing this a lot as we go. 50 ohms plus reciprocal of 60 ohms plus reciprocal of 300 ohms. And one thing, I don't remember if I mentioned this or not, but the total resistance will always, in a parallel circuit, it will always be less than the smallest resistor. So you kind of just get a rough check of yourself. It's always going to be less. So we know that this total, if we do it right, is going to be less than 50 ohms. So let's just try it here. Let's do 50 reciprocal plus 60 reciprocal plus 300 reciprocal equals, and that's 25 ohms. So 25 ohms. And there's some other techniques and some other ways of calculating resistor, but this is probably the most common. We can do, like I said, a couple other methods, and if they're all the same, we can just do however many there are divided by how many. If they were all 50 ohms, you could do 50 divided by 3, and that would be the answer. But since they're all different, this is by far, in my opinion, the easiest way, especially with a good calculator, a decent calculator like that. So 25 ohms. So now we can solve this whole problem, and we can just start right here. This is as good a place as any, and we'll double check ourselves as we go. So we have E and R. So E divided by R equals I. So 24 divided by 25 equals 0.96. So RT is 0.96. Now remember in the prefixes we talked about we need 1 to 3 whole numbers. So we're going to have to change this. So we're going to move it to 3 places to the right, which makes it a bigger number. It was 0.96. Now it's going to be 960. And we'll go down, bigger number, lower prefix, and that it'd be milliamps. So it's going to be 960 milliamps. All right, 960 milliamps. And then when we have that in the calculator is 0.96, I times E equals P. So let's just times 24 and 23.04 watts. That's our power that we're consuming. All right, so that one's good. Now let's try this one. Volts and resistance. Volts divided by resistance equals current again. So 24 divided by 50, and that's 0.48. So 0.48 amps. So if we move it 3 places, and that's going to be 480 milliamps. So 480 milliamps. Remember, 1 to 3 whole numbers. But I'm going to leave it at 0.48 in the calculator and multiply it times the volt, current times voltage equals power. And get my power right there, 11.52 watts. 11.52 watts. And I generally go a couple of decimal places most of the time. Now, we're going to be doing some complex problems later on where we may have to go a little more. But we're right now, round it to a couple decimal places is usually plenty good. All right, so the next one is voltage divided by resistance. E divided by R equals I. So 24 divided by 60 equals 0.4. So we're going to be 0.4. We're going to change that. Put 2 zeros, and that would be milliamps. That would be 400 milliamps. And then I've got 0.4 on my calculator times 24 to get my power. 97.6 watts. All right, that's no problem. Now let's do the other one. Voltage divided by resistance, 24 divided by 300, 0.08 equals 0.08. I'm going to move my 3 places and make that milliamps, so that would be 80. We can drop that first 0, so that would be 80 milliamps. And then I'm going to leave that 0.08 in the calculator times 24 times the voltage to give me power is 1.92 watts. And there we go. Okay, so we can kind of check ourselves here. Our currents all added up should equal the total. So you got 480, 400 is 880, plus 80 is 960 milliamps. That's what we have. So we're good there. The power is always good. Power can always adds up, whether it's series or parallel. So in series you can't add the currents because they're the same. In parallel you can add the currents. In series you can add the voltages, but in parallel the voltages are the same, so you can't. They're all the same. But power you can always add the power up, whether it's series or parallel, and get your total power. So 11.52, 97, that's 108, let's just use a calculator. Why not? We got it here. We might as well use it. 11.52 plus 97.6 plus 1.92 equals 111.04. Uh-oh, what happened? We got some problems here. What did we do? 24 times 0.96 should be right. Oh, wait a minute. .24 times point. So if that doesn't work out, then you need to check yourself. 11.52 and then 400.4 times 24 equals, that's 9.6. This one here is supposed to be 9.6. See? That's how you find out you missed something. So let's try it again. 1.92 plus 9.6 plus 11.52 equals 23.04. So see, I had missed this one. I grabbed the wrong number. And so when I double check myself, I add up these powers and they equal that power. And I figured this separate. So if it doesn't work out, you missed something's wrong. You missed something. So that's a good way to check yourself. So anyway, in a nutshell, that's kind of just the basics of starting out to doing parallel circuits and the difference between series and parallel. And the next time we'll look about doing some combination circuits and maybe using some other formulas and stuff. Thank you.